When sizing 120/240 single-phase service conductors, it's important to refer to the National Electrical Code, specifically Section 310.15 ATWR. This section addresses ampacity requirements for conductors. The question refers to an exception in the 2002 code that allowed higher ampacities for service conductors compared to the general ampacity tables. The 2005 NEC still contains provisions that permit the use of specific ampacities for service conductors in dwelling units under certain circumstances. The ampacity of a number 40 HHN conductor is generally dictated by NEC Table 310.16, which would allow for 70 amps at 60 degrees Celsius, 75 amps at 75 degrees Celsius, or 85 amps at 90 degrees Celsius, depending on the temperature rating of the terminations. However, the 2005 NEC allows for specific ampacities for service conductors as detailed in Section 310.15 ATWR. For a 320 amp single-phase 120/240 service, the appropriate conductor size needs to be determined based on the specific rules for service conductors. NEC Section 310.13 ATWR provides adjustments to allowable ampacities under specific conditions. If the conditions of 310.15 ATWR are met, then you can use the ampacities specified in that section. For example, a number 40 HHN conductor can have an ampacity of 110 amps if the conditions specified in NEC Section 310.15 ATWR are met. Remember to consider all applicable correction and adjustment factors as outlined in NEC Section 310.15. These factors account for ambient temperature and the number of current carrying conductors in a raceway or cable. Ensuring that the selected conductors are suitable for the load and operating conditions is crucial for safety and code compliance. Also keep in mind voltage drop calculations. While voltage drop is not strictly enforced by the NEC, it is recommended to keep voltage drop to a minimum for efficient operation of electrical equipment. Voltage drop can be calculated using various online calculators or software. Consider the length of the conductor run and the load current when calculating voltage drop. Generally, a voltage drop of no more than 3% for branch circuits and 5% for feeders and services is recommended. The size of the service disconnecting means must be rated no less than the calculated load per NEC 220. Also, consider the available fault current at the service. The conductors, overcurrent protection devices, and equipment must have an adequate interrupting rating for the available fault current. Coordination studies should be performed for larger services to ensure proper operation and selective coordination of overcurrent protection devices. This will minimize the extent of an outage during a fault condition. When installing service conductors underground, consider using conductors listed for direct burial. Direct burial conductors are specifically designed for underground installations and are resistant to moisture and physical damage. Also, ensure that the conductors are buried at the proper depth as required by the NEC. When installing service conductors overhead, maintain proper clearances from ground, buildings, and other structures as required by the NEC. Use appropriate insulators and hardware for overhead installations. Ensure that the service entrance equipment is properly grounded and bonded in accordance with NEC requirements. Proper grounding and bonding are essential for safety and to minimize the risk of electrical shock. Consider using surge protection devices at the service entrance to protect sensitive electronic equipment from voltage surges. Surge protection devices can help to prevent damage to appliances, electronics, and other equipment during lightning strikes or other surge events. When making connections to service entrance equipment, use properly sized and rated connectors. Ensure that all connections are tight and secure. Loose connections can cause overheating and potentially lead to a fire. Label all service entrance equipment and conductors clearly and accurately. Proper labeling helps to identify the equipment and conductors and can prevent confusion during maintenance or troubleshooting. Keep the service entrance area clean and free of obstructions. This helps to ensure safe and easy access to the equipment for maintenance and repairs. Periodically inspect the service entrance equipment for signs of damage or deterioration. Address any issues promptly to prevent further damage or safety hazards. The selection of conductors and overcurrent protection should always comply with local codes and regulations. Always consult with a qualified electrician or electrical engineer for assistance with service entrance design and installation. Remember to keep a copy of the electrical permit and inspection reports on file for future reference. This documentation can be helpful for insurance purposes or when selling the property. Finally, always prioritize safety when working with electricity. Turn off power to the service entrance equipment before performing any work. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Electrical safety is paramount. First, always disconnect the power. Before starting any electrical work, turn off the circuit breaker or remove the fuse that supplies power to the circuits. This will prevent accidental electrical shock. Second, use the right tools. Use insulated tools that are designed for electrical work. These tools will help to protect you from electrical shock. Thirdly, wear appropriate personal protective equipment, or PPE. Wear safety glasses, rubber gloves, and other PPE as needed to protect yourself from electrical hazards. Fourthly, never work alone. Have someone nearby who can assist you in case of an emergency. Fifthly, know your limits. If you are not comfortable performing a particular electrical task, hire a qualified electrician to do the work. Sixthly, test before you touch. Use a voltage tester to ensure that the circuit is de-energized before you start working on it. Seventhly, be aware of your surroundings. Watch out for overhead power lines, wet surfaces, and other potential hazards. Eighthly, follow instructions. Read and follow all instructions carefully when working with electrical equipment. Ninthly, don't take shortcuts. Always do the job right even if it takes a little longer. Tenthly, stay focused. Avoid distractions when working with electricity. Always consult the local electrical code and regulations for specific requirements in your area. Understanding the specific requirements for service conductors and residential dwellings, particularly concerning ampacity adjustments allowed by NEC section 310.15 at will, is crucial for safe and compliant installations. This often permits ampacities higher than those found in the general ampacity tables, such as table 310.16. Remember, the ampacity of number 4 THHN can be 110 amps under certain conditions as defined in the NEC. However, it's imperative to adhere to all other applicable codes, regulations, and safety guidelines.